All right, we've talked about double displacement reactions where the two sets are switching partners. There's also what's known as a single displacement reaction where only one thing is getting displaced. And so you should eventually be able to predict the products of a single displacement reaction and then predict if they're going to be soluble or insoluble, or if we're going to form a precipitate, right? So in a single displacement reaction, we have one thing displacing one other thing, right? And in this reaction, this zinc metal is going to displace this silver here. So if we look at what's happening in solution, we have this silver that's aqueous with a plus charge, and we have this NO3 that's aqueous with a minus charge, and we're adding this solid zinc to it, right? And so we can see what the displacement is. This zinc is now going to be with this nitrate, and the silver is going to be by himself. And in this kind of reaction, once that element is by itself, then it is a solid. So one of the products is going to be solid silver. Now this zinc is going to become a cation. And if you remember from your periodic table, there were those metals in the transition area that always form the same charge. You had silver, cadmium, and zinc. And zinc is always going to form a +2 charge. So if he's going to be with nitrate, who has a -1 charge, if we do our cross multiplying, we're going to need 2 of those and 1 of those. So the other product is going to be zinc with 2 nitrates, right? And so then our zinc nitrate is going to be aqueous. So what we end up having is we have the silver comes out of solution and becomes, from the silver cation, becomes actual silver metal, and the zinc solid goes up into solution and becomes the zinc cation. So this is an oxidation reduction reaction. We'll talk more about those later. But one of the things you can kind of see from this equation now is that if we have silver here and our zinc nitrate over here, that we don't have a balanced equation at this point. Right, and so we should just refresh on our balancing. What we're trying to balance is our silver, our nitrogen, our oxygen, and our zinc. And if we look at what we have 1 silver over here, 2 of these nitrates, so we have 2 of those, 6 oxygen, and 1 zinc. And on this side we have 1 zinc, 1 silver, 1 nitrogen, and 3 oxygen. So what we should be able to immediately see is that we have an odd number of oxygen on this side and even on this side. So we're going to want to make this side even. So we're going to need to put a 2 over here. That will double the amount of silver we have and the amount of nitrogen and the amount of oxygen, but we still only have 1 zinc. So now if we come back to the other side of our equation, we can see that our nitrogen are balanced, our oxygen are balanced, our zinc are balanced. The only thing not balanced is our silver. So we'll have to put a 2 there, and then we end up with 2, 2, 6, and 1, and then we have a balanced equation. Right. And so that would be the whole show there of predicting the product and then balancing the equation.